Imagine looking at the world and thinking you understand it, that everything makes sense. But what if I told you that everything you believe about reality is wrong? That the world doesn't follow the rules your mind expects? Richard Feynman, one of the greatest minds in physics, spent his life staring into the heart of the universe and discovered something terrifying and beautiful. Reality is stranger, wilder, and more unpredictable than you could ever imagine. And today, I'm going to show you why the world doesn't work the way you think. Have you ever stopped to think about how much you truly understand about the world around you? Every day we wake up, follow routines, make decisions, and move through life assuming that the universe operates in a simple, predictable way. We assume that cause and effect are straightforward, that objects exist in one place at a time, and that the rules of reality are intuitive. It feels natural to think this way because our brains are wired to navigate everyday life efficiently. But what if I told you that this sense of understanding is largely an illusion? Richard Feynman, one of the most brilliant physicists in history, spent his life confronting this very illusion, and what he discovered is both shocking and fascinating. Feynman often marveled at how humans assume the world works based on appearances. We see a chair, and we know it will hold our weight. We see the sun rise and set, and we assume we understand why it happens. This sense of predictability lulls us into a false confidence. Yet, beneath this familiar surface lies a reality that is far more complex, subtle, and strange than our intuition allows. Feynman's work reminded us that the universe does not follow the simple logic we are comfortable with. Reality, especially at its deepest levels, behaves in ways that challenge the very foundations of our assumptions. What makes this realization so difficult is that it forces us to confront our own limitations. Most of us like to think we understand what we see, but understanding, in the scientific sense, is very different from familiarity. Seeing something every day does not mean you comprehend it. Feynman highlighted this distinction repeatedly. He warned against the trap of knowing the name of something versus truly understanding it. You might know the word electron, but do you understand what it really does? Do you grasp how it behaves under conditions that defy ordinary logic? Feynman challenged us to dig deeper and not settle for surface-level knowledge. The illusions we hold about reality are not just theoretical, they shape how we interact with the world. Our senses deceive us constantly. Light appears to travel in straight lines, but at the quantum level, it moves in ways that defy this assumption. Matter seems solid, yet it is mostly empty space with particles vibrating at incredible speeds. Time feels linear, but the fundamental rules of physics reveal a more flexible, complex tapestry of cause and effect. Feynman's genius lay in his ability to reveal these hidden truths in ways that were both rigorous and surprisingly intuitive. He used thought experiments, simple analogies, and visual diagrams to make the invisible visible, to make the strange feel comprehensible. Feynman also believed that admitting the limits of our understanding was a form of strength, not weakness. Too often, people cling to certainty because it feels safe. But science, as Feynman demonstrated, thrives on uncertainty. To truly see reality, you must be willing to let go of assumptions, question everything, and accept that the universe may not conform to your expectations. This mindset transforms the way you approach learning, problem solving, and even everyday life. The illusion of understanding is comforting, but it is also a barrier. Breaking through it opens the door to genuine discovery and insight. In his lectures, Feynman often encouraged people to cultivate curiosity rather than certainty. He wanted students, and indeed anyone willing to listen, to approach the world with the wonder of a child, questioning even the things that seem obvious. The simplest objects, a table, a candle, or a beam of light, become portals into the astonishing complexity of reality when examined closely. Feynman taught that understanding is not about memorizing formulas or facts, but about observing, questioning, and connecting ideas in ways that reveal the underlying patterns of nature. Ultimately, the first step in Feynman's approach is recognizing that what we think we know may only be a shadow of the truth. The universe is far stranger, more intricate, and more beautiful than our everyday perceptions suggest. By challenging the illusions of understanding, we open ourselves to the full wonder of reality, and we begin the journey of seeing the world not as it seems, but as it truly is. Feynman's insight is both a warning and an invitation. Let go of the easy explanations, embrace curiosity, and prepare to be amazed. When we think about reality, we tend to imagine a neat, orderly world. We picture objects moving predictably, like cars on a road or planets around the sun. But Richard Feynman showed that at the tiniest levels, this intuition completely fails. The quantum world doesn't follow the rules our brains expect. Electrons don't orbit like miniature planets. They exist in what Feynman called clouds of probability, appearing in different locations depending on how, or even if, we observe them. It's a world where certainty is an illusion, and possibility dominates everything. This strangeness extends to light itself. Light behaves in ways that seem impossible. Sometimes it acts like a particle, traveling in discrete bursts. Other times it spreads out like a wave, flowing and interfering with itself. Feynman loved to explain this using thought experiments, showing that the same phenomenon can have two completely different behaviors, depending on how we measure it. To our ordinary minds, this seems absurd. In the quantum world, the act of observation is not passive, it changes the outcome. What we think of as fixed, solid, or real is often just a pattern of possibilities. Feynman often emphasized that understanding quantum mechanics is not about memorizing formulas or following rigid rules. It's about learning to think differently, to visualize a world where nothing behaves exactly as we expect. Particles can be in multiple places at once. Waves can act like particles. And energy can appear and disappear in ways that defy common sense. He described these phenomena not as philosophical musings, but as tangible realities that experiments have repeatedly confirmed. For Feynman, the challenge and the excitement was to grasp the behavior of reality on its own terms, not the way our intuition demands. One of the most fascinating aspects of quantum mechanics is its probabilistic nature. In our everyday lives, we expect precise cause and effect. Push a ball and it rolls predictably. Measure an object and it has a definite position. But in the quantum world, outcomes are never guaranteed. An electron doesn't follow a fixed path, it has a range of probabilities. What you can know is a spectrum of possibilities, each with its own likelihood. Feynman's genius was in making this abstract concept tangible. He taught that reality at its core is not deterministic, it is a vast, intricate web of probabilities. The implications of this strangeness are profound. It challenges the idea that the universe is orderly in the way we imagine. It forces us to reconsider what we mean by real. If particles can exist in multiple states at once, if the act of measurement changes their behavior, then the very foundation of reality is not as solid as it seems. Feynman delighted in this paradox. He would often say that while quantum mechanics is weird, it works perfectly. The predictions are accurate, the experiments confirm it, yet the underlying behavior seems impossible. This is the beauty and terror of the quantum world. It obeys rules, but rules that are completely foreign to human intuition. Feynman also loved to explore the consequences of this strangeness. The quantum world is not just a curiosity for scientists in labs, it's the foundation of everything we see. The technology we use every day, from computers to lasers, relies on principles that defy classical logic. Transistors, semiconductors, and quantum computers all operate in a realm where particles do not behave as common sense predicts. Feynman showed that embracing this strangeness is not optional. It is essential to understanding and harnessing the universe. Ultimately, the lesson of the quantum world is one of humility and wonder. Feynman wanted people to realize that reality does not owe us simplicity. Our intuitions honed for survival in an ordinary world fail when we peer into the microscopic depth. The universe is stranger than we can imagine, but that strangeness is not chaotic or meaningless. It is precise, elegant, and profoundly beautiful. To explore it is to expand our minds, to embrace uncertainty, and to see the world in a way that challenges everything we thought we knew. Quantum mechanics teaches us that the universe is far more mysterious than we can comprehend, and it is in that mystery that the true wonder of reality lies. One of the most astonishing ideas Richard Feynman explored is that reality itself is affected by observation. In the quantum world, the act of looking is not passive. Particles behave differently when they are being observed. This is not science fiction, it is experimental fact. Feynman often emphasized that the universe at its smallest scales does not exist independently of measurement in the way we imagine. What we see is influenced by the very act of seeing it. This idea is counterintuitive, and yet it has been repeatedly confirmed by experiments with electrons, photons, and other subatomic particles. The universe behaves in ways that defy the rules of everyday life. Feynman loved to explain this through thought experiments, imagining what would happen if we tried to watch a particle. He showed that when you attempt to measure its position, its behavior changes. A particle that might have followed a range of possibilities suddenly chooses a path because it has been observed. In other words, reality does not merely unfold in a fixed way, it responds to our interaction with it. This is a radical departure from our common sense understanding of the world, where objects exist independently of whether anyone is looking at them. In the quantum realm, the observer becomes part of the system. The implications of this principle are profound. It forces us to question what we mean by reality itself. If observation changes outcomes, then reality is not something static that sits waiting for us to notice it. Instead, it is dynamic, participatory, and strangely intertwined with our perceptions. Feynman often pointed out that this does not mean we can make reality whatever we want. Nature still follows strict rules, but those rules operate in ways that are fundamentally different from what our intuition tells us. This subtle interaction between observer and observed is one of the reasons quantum mechanics has remained so perplexing to both scientists and philosophers alike. Feynman also emphasized the beauty of this paradox. Rather than being a limitation, the fact that observation affects reality is a doorway to deeper understanding. It teaches us that the universe is far more interactive than we ever imagined. We are not passive spectators in the cosmic theater, we are participants. Every measurement, every interaction, every attempt to understand the universe subtly influences it. This realization encourages humility. We are not masters of reality, we are explorers within it. The more we probe, the more we uncover the surprising, elegant, and often bizarre ways that nature operates. Another fascinating consequence is how this principle reshapes our approach to learning and discovery. Feynman believed that to truly understand the universe, we must embrace uncertainty and unpredictability. We cannot rely solely on assumptions or intuition. Observation becomes an act of engagement, of dialogue with reality itself. By carefully measuring, experimenting, and questioning, we begin to see patterns emerge. But those patterns are never exactly what we expect. They challenge our preconceptions and force us to develop new ways of thinking. In this way, observation is not merely passive, it is an active process of uncovering the hidden rules of the cosmos. Feynman often illustrated this principle with simple, yet powerful examples. Light passing through slits, electrons behaving like waves, particles appearing in multiple places. All these experiments showed that measurement is not neutral. The tools we use to explore reality, the act of observation itself, is inseparable from the phenomena we seek to understand. It's a humbling, mind-expanding realization. Reality is not just out there, waiting to be recorded. It is in constant interaction with us, and understanding it requires acknowledging our role in shaping what we observe. Ultimately, the lesson Feynman wanted to impart is both challenging and exhilarating. Reality is not as fixed as we assume, and observation changes everything. The universe is interactive, mysterious, and astonishingly intricate. By observing, questioning, and experimenting, we do not just witness reality, we participate in it. The strangeness of the quantum world is not a limitation, but an invitation. It is an opportunity to expand our minds, to see the universe in ways that are as beautiful as they are unexpected. Feynman showed that to truly engage with reality, we must embrace uncertainty, marvel at the unexpected, and accept that the universe often defies our intuition. In doing so, we discover a world far richer, more dynamic, and more extraordinary than we ever imagined. After exploring the strange and unpredictable world of quantum mechanics, Richard Feynman wanted us to understand something deeply important. Reality may not work the way we expect, but its surprises are what make it breathtakingly beautiful. The universe is not a dull, predictable machine. It is a living, dynamic system full of mysteries waiting to be uncovered. Feynman believed that embracing the unexpected, rather than fearing it, is the key to truly appreciating the universe. The strangeness that shocks us is the very thing that sparks curiosity, wonder, and discovery. Feynman often said that science is not just a collection of facts, formulas, or measurements. It is a way of seeing, a way of thinking that allows us to uncover patterns hidden within chaos. The world is full of astonishing phenomena that defy common sense, from electrons existing in multiple places at once to light behaving as both wave and particle. These are not anomalies, they are fundamental aspects of how reality works. For Feynman, the beauty of these discoveries lies in their ability to challenge our assumptions and expand the horizons of our imagination. What makes this perspective so powerful is that it transforms the way we approach life itself. If we expect the universe to always behave in familiar ways, we close ourselves off to discovery. Feynman encouraged us to embrace curiosity, to ask questions even when they seem uncomfortable or impossible. He believed that the joy of science and the joy of life comes from exploring the unexpected, from uncovering truths that surprise, delight, and sometimes even frighten us. Each discovery is a glimpse into the deeper order and creativity of the universe. Feynman also showed that this approach is not limited to physics. The mindset of embracing uncertainty, questioning assumptions, and marveling at the unexpected can be applied to any field, any problem, any pursuit of knowledge. It teaches us humility because no matter how much we know, the universe will always have secrets we cannot predict. At the same time, it fuels courage because the more we explore, the more we realize that the strange and the unfamiliar are not threats. They are invitations to grow and learn. The universe rewards curiosity in ways that our instincts and intuition alone cannot anticipate. One of Feynman's most inspiring messages is that understanding the unexpected requires imagination as much as intellect. To see the universe as it truly is, we must stretch our minds beyond everyday experience. We must visualize possibilities that seem impossible, accept contradictions, and hold uncertainty without fear. This is not easy, but it is exhilarating. Feynman often described this experience as playful and joyous. To him, science was not a duty or chore, it was a form of adventure, a way to dance with the universe and discover its hidden rhythms. The beauty of the unexpected is also a reminder of how fragile and precious our knowledge is. The rules that govern reality are precise, yet they often defy our common sense logic. What we think we know today may be overturned tomorrow. Feynman celebrated this uncertainty because it drives innovation. Every new observation, every experiment, every challenge to assumptions pushes humanity closer to understanding the deeper truths of existence. The unpredictability of reality is not a flaw, it is the engine of progress, creativity, and wonder. Ultimately, Feynman invites us to look at the world with fresh eyes, to marvel at the strange, the counterintuitive, and the mysterious, to accept that reality may never conform to our expectations, yet in that very strangeness lies its greatest beauty. By embracing the unexpected, we cultivate curiosity, imagination, and a sense of awe that can transform the way we live, think, and experience the universe. Feynman showed that the world is not meant to be boring or predictable. It is meant to inspire, to challenge, and to amaze us at every turn. The more we explore, the more we realize that reality is not just something to understand, it is something to marvel at, something to celebrate, and something that will forever ignite our sense of wonder.